Okay, so now we're ready to kind of move into the second half of chapter 1. And hopefully this information that you see is not going to be brand new. It might be stuff that you're like, I've seen that before, but I don't completely remember. And if so, that's okay, because we know last year in 4th grade, we kind of had some interruptions in your 4th grade year. But what we're going to be getting into today is talking about these addition and subtraction properties and rules. Now, these are things that you will see in 6th grade, in 7th grade, in 8th grade, and maybe even some in high school. Because do you remember that PEMDAS thing we talked a little bit about? Isn't there parts of PEMDAS that has addition and subtraction? Yes. So see, that's kind of the next level that we're in. And because addition and subtraction never goes away, it always kind of re-pops up somehow, some way. We've got to make sure that we understand how addition and subtraction truly work. Okay? So for that reason, we're going to talk today about these 3 different properties. So let's take a minute and let's start our notes today. We're going to call this lesson 5. Okay? So this is chapter 1, lesson 5. You might want to, when you do your notes, I always recommend that you keep them organized so that come time for like a test, you know exactly what you have to kind of prepare for. All right, so in lesson 5 today, the first property we're going to kind of play with is called a commutative property of addition. Commutative property of addition. Who can read me? What is that saying? What's it say, Addison?
Changing the order of add-ins does not change the sum.
Now, it used the word add-ins in there. Addison, what is an add-in?
Just like remember that you add to the problem?
Yeah. It's weird how in like math now they use like fancy terms for something that means something so basic. But an add-in is basically just a number that you use to add together to create a sum, an answer. So in this property, it says, we can change the order of how numbers sit, and it's not going to change our answer. Which is kind of a cool thing to recognize. So I would include the example. This is a real basic example, but the example tells me if I start with an easy problem like 8 plus 7, and I add those 2 numbers together, I'm going to get what sum? What am I going to get, Connor, when I add 8 plus 7?
15.
15. Does it matter if I reverse that and do 7 plus 8? Am I still going to get 15, Connor?
Yes.
Yeah. That's what that property, that's what that rule says. No matter the order, if everything that you're doing in there is addition, the answer's going to stay the same. Have you all heard of this property before?
Yeah.
Okay, good. Sometimes on tests or quizzes, you have to like state what property is being used. So they might give you an example and they'll ask you, what property do you see? So if they gave you that example, 8 plus 7 is the same as 7 plus 8. You would respond with the property is the commutative property of addition. Now you gotta be careful and always remember to put that of addition part. You know why? Does anybody know why? Why does of addition matter? Why can't we just put the commutative property? Why? Yes. There's also commutative property of multiplication. We got to make sure that we are identifying what real property that is. All right, let's look at the second property. Yes.
I'm still not memorizing.
It's okay. away. The slide's not gonna go away. The second property is called the associative property of addition. So again, the of addition is important because there's also one of these in multiplication land. So here's what the associative property says to do. It says that we can group addends together, and if we change how we group them, it's not gonna matter because the sum's still gonna stay the same. So if you look at that example, it's got 9 plus 4 in parentheses, and then outside the parentheses it says plus 6. Who can solve that for me real quick? If I have 9 plus 4 in parentheses plus 6, Brandon, what do I have?
19.
I have 19 there. Yes, so I have 19. Now, if I look at the other example, where I moved my parentheses to different numbers, I still have a 9, a 4, and a 6, but this time, my 4 and my 6 are inside the parentheses. What am I gonna get as my sum?
19.
Still gonna get 19. It's not gonna change. Why do you think it didn't change? Why did the sum not change? Right. Xander, why did the sum not change? Right, our add-ins didn't change, did they? The add-ins are the same. And that's a very important thing to recognize. If the add-ins change, will the sum change? Yes. So because in this example, the add-ins didn't change, it didn't matter how I grouped them. What do you notice is the difference between the commutative and the associative? Come on, some new hands. I'm seeing the same people wanting to volunteer every single question. But remember, how I know that your brain is learning is by you sharing what's inside your brain with me. Tessa?
One has parentheses and the other one doesn't.
Exactly. That's the major difference. So as you are searching for what property this thing is, the one with associative has the parentheses. Now, does anybody have a fun way that you can kind of remember that the one with parentheses is the associative and the one without the parentheses is not? What do you think? You have an idea, Addison?
The idea is that A starts in the beginning of the alphabet and the parentheses start first.
Ooh, that's an excellent way to try to remember. So, I don't know if you heard what she said, but because we are in like level 2 of math, right? But we kind of explained it like a video game the other day, and we said, like we kind of beat the beast, and so now we're moving into the second level. So in this level, we now are gonna see this a lot, this PEMDAS stuff a lot. And she said that P is the first thing that we do. P is parentheses. And she related that in her brain to the letter A, which is what starts the associative properties in. The letter A is the first letter of the alphabet. So in her brain, she says, I kind of can remember that associative goes with the parentheses because parentheses is what we do first, and A is the first letter of the alphabet. That's how it works for her. Anybody have any other tricks to help you to remember?
It's doing this, like parentheses are doing this, like they're raising their hand, like start me first.
Okay,
That's
so
what Miss Cox taught us.
so the parentheses are kind of like raising their hands. So how can that help you to remember that the one that has the parentheses raising their hand is the one that goes with the associative? But you're right, yeah, it is kind of like wrapping their arms around.
So you start like the parentheses first,
Okay,
and then you add them to the 6 right there, like the 9 plus 4 in the parentheses. You add that together and then you add the 6.
yeah, and that's how we get our answer. But my question to you, Ellie, is this: how do I teach my brain that the problem that has the parentheses goes with the word associative property of addition? How can I train my brain that this property name goes with the one that has the parentheses and not that one? That's what we're trying to figure out. How could we, like, sometimes when we're trying to remember this kind of stuff, if we give our brains kind of like fun tricks to kind of remember, then it sticks up there and it's easier for us to recognize. Yeah, Sophia?
So I usually like doing fun tricks, like usually if I write down the notes, I'm just remember it.
So yours is just kind of your memory does that on its own?
Yeah.
Well, Addison gave us all like a really good kind of tip. So if you're looking for a way, if you're not like Sophia, where just writing it down helps you to just know it, but you're somebody who needs to kind of like have that trick that kind of helps, maybe you could do what Addison said, which is think parentheses first, associative with the A. A is the first letter of the alphabet. They both at the first, so that trick teaches my brain whenever I see a problem that has parentheses, I'm going to know that goes with the associative property. Maybe that's how. Now, other than that, maybe you got to think of what works for you. But those are just kind of some tricks. All right, the last property that we're going to talk about today is the identity property of addition. And again, there's one of these that goes with multiplication. So that addition is important. But the identity property says the sum of 0 and a number is that number. So if you have a number plus 0, your answer will always be that number. Now, will this work that way with the identity property of multiplication? No. How's it going to change? How's it going to change, James?
Because 0 times whatever number is actually 0 instead of that number.
You got it. Excellent. So with the addition property of this one, your answer will always turn out to be the number. With the multiplication property of identity, it will always end up as a 0. Yes? Yes, I guess these can they kind of wrap themselves together. Yeah.
So that's not something that was wrong.
Make sure you have these 3 pieces of information in your notes, because here in a minute we're going to jump away from this slide. The slide's not going to be up here for you to see it, and we're going to practice some. So you're going to probably need your notes to kind of go back to, maybe for help. All right, are we ready to jump to our next slide? Everybody got this? A few more minutes? I'll give you about 1 more minute to get all this down. It's kind of been up there for a while. Right, it's so important. I know it's early. I know it's only 9 o'clock in the morning, but we're getting our brains moving. Did y'all eat breakfast today? Good. Breakfast is brain food. You didn't. That's probably why you're sitting there kind of half awake. Breakfast is brain food. Make sure you eat it in the morning. Yes, Mason. Yes. What?
I think the only reasons why I really feel okay is my brother didn't want to do it. I was just yelling at my mom.
So that kind of woke you up a little bit. All right. What? What? That's good. That's all right. It's something to kind of feed your brain. All right, so let's try some. All right, here we go. So we're going to practice. I want you to name the property of addition that is being used in each of these examples. So the first thing you're gonna do is fill in what's missing, because there is something missing in this number sentence, or this addition sentence, or this math sentence. There's something missing, so it's kind of like in reading class or in communications class when you have to fill in what's missing in the sentence. Well, you're doing that here too with math. It's just not gonna be a word, it's gonna be a number. And then you're gonna tell me what's the property. All right, so there are a total of 3. I'm gonna give you, let's do a minute and a half.
Can we just put like communicative?
You have to fill in what's missing on the blank line, and then you tell me what property it is.
So we just have, on the property, should we just put communicative, associative, and?
No, it has to say of addition, so I know that you know it's of addition and not of multiplication. Which I know that you do, because it's all that we've done, but we gotta train our brains to do the right ones. Question. You don't have to solve it, you just have to find what was missing and what was missing, but you did. Now you just have to tell me what property this is. Yeah, maybe we'll move that. This is okay. It's not, maybe we'll move that. Yeah. Bring this on in. And it's kind of a, was it a in front? Yeah, so let's just move your whole seats versus, we'll do this one. All right, Tiff. Number 1, who can give it to me? I want to know what number is missing and the property that is being used. Let's see. I haven't heard Colin yet. Colin, what number is missing?
19.
Yes, and what's the property?
Community property of addition.
Beautiful. Who got it? Everybody? Good. Number two, Allie, what's missing?
258.
And what's the property?
Identity property
Of addition. Identity property of addition. And then number 3, Rory, what's missing? 37, and what's the property? The associative. Beautiful. How did you do on those 3? Those were pretty simple. Tonight, when you have a little assignment that you're going to work on, and here we're probably going to have a couple of minutes in class to get started on it, you're going to have problems like that, okay? Where it's going to give you some examples, and it's going to say to list the property that's being used. All right, let's try some other ones. What about the next 2 examples? This one says show 2 ways to group these add-ins. So if I'm going to group them, what property am I playing with? Addison. If I'm grouping them, I'm not playing with them. Associative, very good. So I'm going to be playing around with the associative property. But I want you to take these, like for number 1, take the number 6, 4, and 7. and show me ways that I could group them to show the associative property so that I get the same answer. Do that for number 1 and for number 2. 30 seconds.
You solve it.
Nope. Remember, you've got to show me 2 ways. So for number 1, I should see those numbers with parentheses in one place, and then you're going to show me those same numbers with parentheses in a different place. That's how I understand that you know how to group these things in 2 different ways. All right, I'm going to have somebody come up here and show me. Let's do number 1. Lily, come on up. Lily, come on up here, babe. Use the smart board. She's going to do the first problem for us and show us how to group those digits. I think we had a 6, a 4, and a 7 maybe. Hang on, hands down for just a minute while she works through this problem. Good, that's one way to group them. Excellent, Lily, nice work. Now, did you have to put the 7 and 6 in parentheses? No. I mean, that's how she chose to do that. But there could have been another way that you could have grouped them as well, right? How else could you have grouped them? Go on up there, graded, and show me what could be one more way that you could have grouped those. There you go. So any of those 3 options are there. Can you move the numbers around? Do they have to stay in the order of 6 and 4 and 7?
No.
No, because the commutative property tells me that I can flip them all around as long as everything is addition. And all that I see in this problem is addition, so that means I have the rule says I can do that. If one of those signs wasn't addition, but it was subtraction, would that change things? Yes. Then it no longer becomes the property of addition. If everything inside there isn't addition, like if one of them is subtraction or multiplication, then it doesn't fit the property anymore. Okay, let's try the second example. Head on up, Hallie, go. Do number 2. I don't remember what numbers were. I think that was 10, 2, and 8. Can you go up to the top and pick a different color? Just click, see up at the top where it says the different squiggly colors. Just pick one so that people at home see the difference between these 2 examples. Go. Now, so I'm kind of walking around and I'm looking at some of your notebooks. I'm noticing that some of you did not group them 2 ways, you only grouped them 1 way. If on a test or a quiz it says to group them 2 ways, make sure you have 2 different ways. Okay, that's one way. Beautiful. What would be the last way? Sophia, come on up. Show us one more way that we could improve those. So, wherever you want to put it. What hasn't she proved yet? I need to get the eraser. That's okay. Here's your eraser. Right there. You gotta put your pin back up. Get the little pin picture. Yeah. And it's already set to red. Up. There you go. That's the third option. Perfect. All right, questions on this? So you all feel pretty good. This isn't big brain busting stuff. This is kind of review, so hopefully you feel pretty comfortable. All right, let's look at that last little example that we were going to play with. So the last example, I know there's a little bit of stuff kind of hidden. Let's see if we can kind of see. I can tell you problem number 1 says 12 plus blank equals 21. So everybody write that one on there. 12 plus blank equals 21. And the direction says to find the unknown added. What does that mean? What are those directions? What are they asking you to do, right?
Find this.
Find the missing number. Remember,
12 plus what equals
What's the second one?
21.
What's the second?
The second line just says number 2, like this is problem number 2. So it says blank plus 75 plus 42 plus 25 equals 150. All right, now, before you start to solve this, let's figure out what could be the fastest way that I can do this. Because for question number 1, I am playing with some pretty small numbers, but do you think in math world it's gonna always be this small? No. We keep things simple as examples, but it's not always gonna be this way. So if I was looking at a particular problem and I had to find a number that was missing. So for this example, it said 12 plus blank equals 21. And you had to figure out what the blank number was. Now, many of you, because you're 5th graders, are sitting there going, oh, that's easy. Because I know that 12 plus 9 equals 21. So that was like the fast, easy way for you to come up with your answer. And that is the correct answer. However, what happens when things get a lot bigger and harder and you're looking to have to find the missing number? What could you do if you were playing with numbers that are bigger that you couldn't find the answer that quickly? What could you do? Allie?
You can do subtraction.
Yes, you can do the opposite. Because opposites will always help you find what's missing. So rather than just asking your brain, 12 plus 1 equals 21, take the 2 numbers they give you, which is 21 and 12, and do the opposite of the math that you see. Since I see addition, the opposite of addition is subtraction. So I could do 21 minus 12, and that helps me to figure out that what's left over is 9. Okay? So that's important that you recognize that because it won't always be as easy as 12 plus blank equals 21. It might be something like, 846 plus what equals 1,692. And you can't do that in your head as fast as you can do 12 plus 9 in your head. So you would need to know what you could do to quickly find that answer And what is it that you do, everybody? The opposite. So if this was a multiplication sign sitting there, what's the opposite of multiplication, everybody? Division. If this was a subtraction sign sitting there, what would you do? So we do the opposite, okay? So let's jump back to the one that we were playing with and make sure that we can figure out the missing number. All right, hopefully that'll go away in a moment. So blank plus 75 plus 42 plus 25 equals 150. What are we gonna have to do first to find the missing number here? Mason I, or Mason W, what are we gonna have to do here first? On this bottom problem. I have a 75, I have a 42, and then what else did I have? Thank you. All right, Mason. So my problem said blank plus 75 plus 42. 42 plus 25 equals 150. This is our problem. Before we can just start doing the opposite, what do we have to do, Mason? We're not going to subtract anything yet. Because we've got a whole bunch of stuff sitting right here that we have to do something to first. What do we have to do with all that stuff first? What is the problem telling us to do? Huh? Add it. We got to add all that stuff together. Because I can't even begin to figure out what to subtract until I get a number. And right now I don't just have one number, I have three numbers. So what is 75 plus 42 plus 25? What is it, Colin?
Isn't it 142?
Yes, it is. It's 142. Easy. So now I have a problem that looks kind of simple. I have blank plus 142 equals 150. Now I could subtract if I needed to. But some of you are like, this is easy, I can do this in my head. What number do I still need to get me to 150? James? 8. 8. And that's our final answer. Okay, so you have about 9 minutes left. So here's what you're going to work on doing. We are going to take a minute. Your activity is to complete workbook pages 11 and 12. So everybody get your workbook page out. You have 9 minutes of this class left. This is a homework assignment, but if you work hard right now or in WIN class later today, you will be able to knock this out. So turn to page 11 and 12. And this is lesson 5. We just completed lesson 5. Yes, Brady. If it says yes, because I want you to train your brain. So Brady's asking, do you have to write the whole thing out? No, you can abbreviate it. You can put like COMM of addition. You don't have to write the whole big word. Let's check out page 11 really quickly and make sure that everything on this page we understand how to do. So on page 11, the first part that you have to start answering says find the unknown number. So you're looking for the number that's missing, and then you have to name the property. Did we learn how to do that today? Yes, so those 2 questions at the top should be easy for those first 3. Then we move to 4, 5, and 6, or just 4 and 5, sorry. And it says, what is the difference? Select the correct answer. So you're searching for the answer. That's pretty simple. And then 6 through 15 says find the unknown added. And again, what does added mean in math world?
The 2 numbers
the number. So find the number that's missing to get the answer that they want. And if you can't figure it out super quickly in your brain, then what can you do? The opposite. Okay. Turn to page 12. Let's check out that page and make sure that there's nothing that's going to trick us on that backside. All right, on page 12, it says show 2 ways to group the add-ins. We did that, so we should know how to do that. And then number 5 is a little bit of like a, not a word problem, but it just kind of gives you a little bit of word problem. Number 6, 7, and 8 are word problems, so you have to kind of read through those. Remember, the last sentence is always where the question is located. And then number 9, we do not have to do the right about. So you can kind of cross that out. You may get started. It depends. No, because I give you opportunities for extra credit, and so those are the times that you earn points. And you can do them if you want to, but it's just for like your enjoyment.